So here they are asking you about which formula represents the empirical formula of a compound. Okay, so empirical formula is going to be something that has the simplest ratio. So we need to look at which one has the simplest ratio over here. So the simplest ratio that I can see over here is going to be, you can see this one. Okay, 2, 4, 1. Okay, the rest, okay, you can still divide by 2, you can still divide by 6, you can still divide by 2. So the answer is going to be A. Now, number 2, the structural formula of compound Q is shown. Now, this is going to be important. Now, how many stereoisomer can exist in this structural formula? So this one, it is very important. Okay, I'll just give you 2 minutes, okay, to see. Okay, and then you try to identify how many.
Sir, in the first carbon ring, the V, is that hydrogen or carbon?
No, this is skeletal formula, Josh. So if you see V over there, okay, that is going to be carbon. Okay, because
So
when we do,
groups?
yes, when we do this, okay, when we do this, this means at the end of this line is always carbon. Okay, so it's always carbon. Therefore, okay, when you have this V over there, it means that this is not attached to hydrogen, it is attached to carbon. If it is attached to hydrogen, the line will not even be drawn. Okay, the line will be missing. You can see there is no line over here. Okay, but they are attached to hydrogen. That carbon is attached to hydrogen. Okay, anyway, that is the simplest part.
So if it's ethene, is it just 2 lines? So it's just 2 lines. I can't.
Ethane. You mean ethane?
Ethene.
Yeah.
Ethene.
So if it is going to be 2 carbon, so it's just 1 dot, just put like that, and then like that. Done. 2 lines. To answer that, it's 2 lines. Yep. Or you can draw like this. Okay. So anyway, so coming back to this question, okay, I want to identify how many stereoisomer, right? Stereoisomer exists in this structure formula. So we have, when we are identifying stereoisomer in our syllabus, okay, we study only 2, okay, cis and trans and optical isomer, okay. So please have a look at which one, okay, that can give you cis and trans first. Now, if you look at cis and trans, you must look at the double bond, but not all double bond will give you cis and trans. This is very, very important. Now, Jordan, do you think there are 2 double bonds here? Do you think both of them, okay, both of the double bond will give you cis and trans? Or if I give number 1 and 2, which one for confirm you know that it's going to be cis and trans?
1?
Yeah, 1. Why is that, Josh? Okay, to answer that, quite simple. Yeah. Why? Because you see here, there is carbon, so one different group, another different group. Okay, there is hydrogen here, one different group, another different group. So if I want to draw cis and trans, I can just change the position of the groups. Okay, so that is going to be related to position number 1. Yeah, let me put. Okay, but how about number 2, the double bond involving number 2? If you look over there, yes, okay, you have one group. Maybe if you assume maybe one group here, there is hydrogen, one group. There is another group over there. But my question is, okay, these 2 groups, okay, the one that is attached to C double bond, let me just draw it something like this. Okay, just imagine, uh, let maybe I don't draw exactly, but let's say I put it in this way. If I put Cl here, and I put something like this. Okay, when I they are connected. Okay, these two groups between carbon, they are connected. Now, if they are connected, do you think there is a way to change the position of the group that is interconnected to that double bond? Can I form cis and trans over here? There is no possible way, because if you look at this C double bond C, okay, if I have X, Y, Y, I can also form CX, X, Y, Y, something like this. But can I do the same thing over here? The answer is no, because the movement is going to be totally restricted because they are connected. Okay, so to answer that, okay, which double bond will be taking part in forming the cis and trans over here is going to be only this double bond. Okay, only that double bond, because in simple words, the groups are independent. Okay, in simple words, the groups are independent. They still satisfy, okay, whether they can form cis and trans, okay, but in theory they cannot. Okay, they cannot, because they are not going to be able to move. Okay, we cannot rearrange them. Okay, we cannot rearrange them. So only one here, but we also need to look for another one more. Okay, which is going to be your chiral center. Now, looking for chiral center, this is carbon, yeah. Okay, carbon attached to 3 hydrogen. So let's look for chiral center. Not this, not this, not this. Okay, I hope when I say not this and not this, you understand what I'm doing. Okay, the double bond, whenever the carbon has double bond, no. Okay, and you must have 4 different groups here. Yeah? So this one, no, 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 also no, also no. This is automatically 2 hydrogen, so cannot. 2 hydrogen, cannot. You can see 2 carbon over here, so this one cannot. This is also cannot. So you can see here, there is 1 hydrogen. So different group, different group, different group. So this is a chiral center. Okay, there is a chiral center there. Now, if there is a chiral center, use the formula that I taught you. 2 to the power of n. N is going to be the number of double bonds that will give you the rise to stereo cis and trans, and also the chiral center. So here, there is 1 here and there is 1 here. So you just use the formula 2 to the power of 2, okay, which is going to be 4. Do take note, I took all these questions from almost 10 or 12 papers. Each set is taken from the from different variations. So it means that whatever questions that I have over here, okay, I have about 32 or 31 questions over here. Now, all these questions are compiled from many papers. So if you think that we are always, how come we are using this formula 2 to the power of n and so on, it's not that frequent. Okay, I want you to understand, they don't ask this frequently. Okay, it just, when they ask, I want you to be ready. This is very important. When they ask, get ready with that formula, utilize the formula. Yeah. So in this case, the answer is going to be, how many stereoisomer? This is going to be 4. 2 to the
Sir,
power. Yeah.
Why is there only one system? So the other one not system. I still don't get it.
Louder, can it?
Why is there only one system? Because I don't get why the
Yeah.
carbon double
So
bond.
you see, just now I mentioned about this. Okay, if you have X, X, Y, Y. If I want to put it as a trans, I will put it in this way. Okay, there is a possibility for the group to move. Okay, but now when you look at this structure, you can see that the free moving is going to be the one like extended is this group, and also this hydrogen extended is okay, it's fine. Okay, the CH3 and H is fine. But the problem is this group, the one that is attached to here, you can see they are forming a cyclic. Okay, it means they are going to be something like this. Instead of joining like that, okay, if I draw, maybe they are going to be joined something like this. Okay, so when they are joined like this, is there a way to take out this group and put it alone in this position and get a trans configuration? The answer is not possible. How you are going to do that? It's not possible. Can you understand this, Kenneth? Okay, so in order to do that, you must have individual groups. Okay, so this is what I want you to understand, because this is what I found out also. They like to test on this as well. Yeah, so here, okay, let's continue. So these are all easy questions. You can see here, what is the name of compound X? Yeah, Josh.
Sir, in the last question, how did we know that was a chiral carbon?
Who? How do we know there is a chiral carbon? Okay, good question also.
In like the carbon that you circled, how do we know that
How
was
do
a
we know
chiral
it's a
carbon?
chiral carbon? Yeah, because we just want to look for 4 different groups. Okay, so you can see that this is the carbon. Yeah, this is the carbon. You can see that they are going to be attached to this particular group. This entire thing. This is one group. Okay, and then they are attached. Carbon has 4 bonds, so there is one group of hydrogen. And then here, okay, the part that is similar to what we have for the cis and trans just now, you can see that they are arranged. Okay, the carbon over here, okay, they are attached to this entire group. Okay, like this entire group. And if you follow from this side over here, even though they are connected, okay, even though they are connected, if you follow from this side, they are counted as a different group. So it's like if, let's say, for example, if you have something like this, okay, if you have another Cl here, okay, if you have another Cl over here, we count the group that is attached to this carbon as different compared to the group that is attached to this carbon. Okay, so this one may be confusing. Definitely, I do agree, it is confusing. Okay, but the idea is, okay, whenever you have, okay, something connected, okay, something connected, if you can see that, you can determine that they are different. Okay, the groups are different. Even the problem will be more towards identifying this group, the one that is attached over here, and the one that is attached over here. They are different. That's going to be the problem, which I agree. Okay, which I agree. Okay, but this one, okay, please learn as we go. Okay, so this one is going to be the Chiral Center, because they are different groups. Okay, so let's not waste time so much on this. Okay, so this one is going to be, you just identify. Later when we see more questions, you will understand more, right? So here is going to be definitely 2 to the power of 2. Now, what is the name? Okay, what is the name of compound X? Okay, so here, okay, we have this compound X, and then I want to name this. So whether it's going to be cis and trans, okay, so how do we do? Okay, so this one is going to be H, okay, and then this is going to be H. So if I draw this, okay, I can simplify by drawing this like this, and then there is H here, there is H here. Then there is carbon, there is OH, there's CH3. And then here, okay, it's going to be carbon. Then after that, join together with CH3. Now, if I want to name this, okay, I know first it's going to be trans, okay, because why? Okay, you can see it's a cross, okay. So this is definitely trans, but I do not know what is going to be the overall name. Now, naming the overall, okay, you follow the same method, FLOP. Okay, find the functional group. So functional group, there is a double bond, and there is also alcohol. So priority is given to the double bond. Okay, so then find out the longest carbon chain. So let's find out the longest carbon chain. You see here. This is the longest carbon chain. So how many carbon? 1, 2, 3, 4, 5, 6. Okay, 6. So it must be hex. Hex, 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 hex. Fine. Okay, hex. So here, identify the double bond at what position? 1, 2, 3, 4, 5. If I follow here, 1, 2, 3. Still at position number 3. So automatically, this is gone. This is gone. Okay, so it must be hex 3 in, hex 3 in. Now, if that is 3, automatically the carbon, this is carbon number 3, carbon number 2, carbon number 1, 4, 5, and 6. And you see the OH is attached to position number 5. So this is going to be 5-hydroxy. See.
Oh, wait, sir.
Mm-mm.
Why not two, sir? It works from either way.
Yeah, that's why the priority is given. Okay. Why not 2? Yes, actually, Nevan, you're correct. Okay, so I think I'm wrong also because it can go 2 ways. Yeah. Okay, because it can go 2 ways. You see, we took it as the priority is 3. Okay, we took it as priority 3. I put it over here. But it can also be carbon number 1 here, carbon number 2 here, carbon number 3. So here, this is going to be special case, yeah? So this one I'm wrong, okay? This one I'm wrong, okay? So here, instead of putting it as 5, because the best way is going to look, represent, instead of this is 1, instead of representing this is 1, so it can go both ways. So this is carbon number 1, this is carbon number 2, okay? So we always look at the smallest number, okay? So this is, instead of using 5, okay, you must use the smallest number. So this one, Nevan is correct, yeah? This is going to be A, okay? This is A, because the position, because this one, since this is position number 3, it means that the carbon can be written as 1, 2, 3, 4, 5, 6, or it can also be written as 3 over here. So 1, 2, 3, 4, 5, 6. So we always look at the smallest number. So in this case, it happened to be that the carbon is position number 2. Okay, it doesn't happen all the time. Okay, it doesn't happen all the time. So this one, be careful. So the answer is going to be A for this. Now, so
Sir,
thank you, Nevan, for that. Yeah.
possible to get to C, sir. For example, like if in the task, and then if like the answer comes out like that, if we answer C, is it still correct, sir?
Definitely wrong. It's a multiple choice question. So still it's going to be only one answer going to be accepted. So it's going to be, you need to identify that. So even if I'm the teacher also, when I circle that 5, okay, I am wrong. Okay, I am wrong. So this one you have to be very careful. Yeah. So you must make sure, okay, that you justify all conditions. Okay, that is something that is important. Include all conditions. Okay, mistakes can happen. Okay, but we learn. Yeah, we learn. Now, the definitions of many chemical terms. Yeah.
If it's just hexene, does that mean it's hex 1 in?
Yes. If it is just hexene, then it's going to be hex 1 in. But normally when they write, yes, it's like that. Okay, but I don't encourage you to write like that. Yeah, mention the number. Okay, now the definition of many chemical terms can be illustrated by chemical equations. Okay, which term can be illustrated by an equation that includes the formation of positive ion? So you want to form positive ion. Now, first ionization energy. Okay, what is first ionization energy? For example, if I'm talking about first ionization energy of calcium, okay, it must be gas changing into Ca plus an electron and must be in gas. And you can see it's a formation of positive ion. Okay, so therefore, okay, it's going to be correct. But do remember, okay, this is different chapter. It must be in gaseous form. Yeah. Now, heterolytic fission of a covalent bond. This one we already learned. Yeah. So if you have Cl2, heterolytic fission is going to be, you are going to get Cl plus and Cl dot dot minus. Okay. So you are going to get a positive ion over there. Okay. Heterolytic fission. Enthalpy of atomization. Now, this one we have learned in your energy. Enthalpy of atomization means you are trying to change Cl2 into atom. Okay, so you can see, okay, you can see according to the definition, you are changing it into atom. Okay, not ion. Okay, so therefore the answer is going to be 1 and 2. Okay, so if you follow, I think, yeah, I'll just leave it as 1 and 2. Okay, so because if you have, they mention A, B, C, D, normally this 1 and 2 option is going to be B. Okay, yeah.
Sir, are electrophiles normally considered positive ions?
Again,
Are electrophiles normally considered as positive ions?
yeah, because electrophile, they love electrons, so they are positive ions. Okay, and but the most important thing is they are able to form dative bond or receive the lone pair of electrons. So if they ask you what is the definition of electrophile, okay, you follow the definition that we have learned. So we don't say that it's a positive ion. Not all positive ions, they are electrophile. So they must have the ability to receive the lone pair of electron. Okay, so that is going to be electrophile. And even, okay, the definition of nucleophile, if you look at the definition of nucleophile, it's not must be negative. Okay, the definition of nucleophile is ability to form dative bond or donate the lone pair of electron. So it means that can we have any nucleophile that is going to be non-negative? The answer is yes. Okay, so based on the definition, okay, in this case, when you have heterolytic fission, it happens in this way, but you don't define based on the charge. Okay, so that is going to be important. Now, next. Now, two hydrocarbons have the formula like this. Okay, and then they say if I put them, okay, in form of ratio, okay, I will get this. Okay, this one, maybe to make it easier, I'll just put C4H10. Okay, C4H10, and then maybe I put C8H, they say 4 divided by 10 equals to Y divided by Z. So maybe 2 divided by 8 divided by 20. How to put it? So basically this one is going to be C, let me use this one, H8. Okay, so I have C2H4. Okay, if I have C2H4. So this is a number, a random example that I can bring over here so that it's easier to show, okay, for some students who don't understand. So you see here, they have this 4 divided by 8, okay, is equals to 2 divided by 4, okay, you can see this is 1, okay, divided by 2, so this is 1 divided by 2, okay. So that is the based on the relationship that they give. Now, which of the following is going to be correct when comparing these two hydrocarbons? So when you want to compare, okay, the empirical formula, you can see because of this, the empirical formula is going to be the same. Why? Because they are going to follow 1 to 2. Okay, it means they are going to follow CH2. This is also CH2, the empirical formula. The molecular formula, on the other hand, they are different. Why? You can see here, they are different. Okay, they are different. The relative molecular mass, if your molecular formula are different, your relative molecular mass are going to be different. Okay, there's no doubt in it. Okay, so you just need to put the 12 and then hydrogen is going to be 1. So you times, you will get a different molecular formula, relative molecular mass. Okay, so the answer is going to be same, different, and then different. This is going to be the answer. Okay, quite simple. Okay, in comparison to some questions that I showed. Okay, but this one, the relationship, okay, is very important. Now, which compound does not exhibit stereoisomer? Okay, when you have this kind of a question, it is very important, okay, to find out, okay, whether they have double bond. Okay, because stereoisomer, you are talking about double bond and chiral center. Okay, double bond and chiral center. So see whether they have double bond here. Okay, so when I see here, like for example, this carbon for A, carbon attached to CH3, attached to hydrogen, attached to Cl, CH2, and then C double bond O, H, CHO. Yeah. So here, what I see, there is no double bond. Okay, there's no double bond. And then another thing that I need to look, okay, what I mean double bond means the carbon-carbon double bond. Yeah, carbon-carbon double bond. Then I need to also look whether they have any chiral center. Okay, so here I automatically can see that there is a chiral center here. Why? This is one group. This is one group. This is one group. This is another group. 4 different groups. Okay, so this one will not be the answer. Okay, do the same thing, okay, for everything. Like for example, this carbon is bonded to CH3, bonded to hydrogen, okay, and then bonded to carbon, another hydrogen, and then CH3. So here you see, it's going to be a tricky question. Why they didn't show the double bond? Okay, they didn't show the double bond, but you will know, okay, each carbon must have 4 bonds. So the double bond must come over there. Okay, if not, it's not possible. Okay, so the double bond must come over there. So here, okay, they are asking whether does not, but the answer is definitely this one can exhibit double cis and trans. Why? The carbon is attached to 2 different groups, attached to 2 different groups. So definitely there is cis and trans. So this will not be the answer. Okay, so you do the same thing. Okay, I'll erase this part. You do the same thing for the rest. Okay, so you see the carbon is attached to H2 and then Cl, CH2, C, Cl2, H. Okay, I can see there is no double bond there. Okay, so the only thing is I need to find out whether they have optical isomer. Okay, so look for chiral center. So when I look for the chiral center, 2 hydrogen, definitely no. Okay, and then you see 2 hydrogen, definitely no. 2 chlorine, definitely no. So here the answer is most likely C. Okay, but just to make your yeah, cannot go. Okay, just to make you happy, you just can try again. This one, C, H, Cl, then there is C, there is H, and then there's another Cl. So this one is not complete. So definitely there will be a double bond here. Okay, and then you can see the carbon attached to the double bond has 2 different groups, so they can actually have they can actually have the cis and trans. So therefore, this is not the answer. So the answer is C. Okay, I hope you understand this. Okay, so you need to draw. Okay, you need to draw. Even in the group discussion, I do see some of them, some of you already starting to learn how to draw this, okay, in form of display formula. So this is the best way to identify. Yeah. Now, the next question here is you have the skeletal formula. So this one is valid where Josh was asking us question just now. Okay, which one is going to be carbon, which one is which? Okay, because now this is the part that they will test. Okay, which one is the molecular formula? So you need to understand, okay, which one is carbon and which one is not shown. Like for example, you see this is carbon, 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 and each carbon, okay, they must have 4 bonds. So please check whether they have 4 bonds. This is okay. So they must have 4 bonds. So there is going to be another 2 hydrogen not shown. 4 bonds here is okay. 4 bonds is okay. This is also carbon. There is 4 bonds. So there must be another 2 hydrogen there. And then that carbon is okay. So if you now you want to calculate, you can calculate how many carbon that we have. Okay, I'll show you. Okay, we can do it together. Okay, so 1, 2, 3, 4, 5, 6. Okay, so we can see there are 6 carbon here. Okay, nothing missed. Okay, so all 6, C6. Okay, 6 carbon. And let's look at the number of oxygen that we have. Okay, oxygen must be there. We cannot, in skeletal formula, we cannot eliminate the oxygen. It must be there. So just count 1, 2, 3, 4, 5, 6, 7. 7 oxygen. How many hydrogen? I already put the hydrogen just now. So I'll just circle. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to be 8. So you can see they want molecular formula. So the exact thing, C6H8O7, then that's going to be the answer. Okay, compared to the others, okay, quite easy. Yeah, quite easy. Okay, now next question. Maybe I will not go through everything also. Okay, so maybe now, okay, I will start to skip some questions. You can try on your own. Okay, you see here, the chlorine oxide free radical, okay, is produced by the reaction between chlorine atoms ozone. Okay, which features are present in chlorine oxide free radical? It means this one, yeah. Okay, they are asking which one is going to be present. Now, the odd number of electron. Now, please remember, even though Cl, a simple free radical, is represented like this, if you are representing like this, basically, they supposed to be like this. They have 7 valence electron, yeah? So, of course, okay, free radical, you need to remember, okay, the moment you have 1 unpaired electron, okay, it means they are going to have odd number of electron. Okay, it doesn't matter they are joining or what, okay, they will have odd number of electron. And in this case, okay, in this case, ClO dot, do they have single covalent bond? The answer is definitely yes. Why? Because Cl supposed to have 7 valence electron, so must have 1 electron that is being shared by the oxygen. Okay, so must have a single bond. Okay, if not, okay, it's not possible to give double bond. It's not possible to give 2 electrons from oxygen to Cl. Okay, so this is going to be single bond. This is not really, it's actually combined. Okay, this is not only organic chemistry. Okay, it's combined. Yeah, so please take note of that. Dative bonding and so on is combined. So a dative covalent bond, okay, from oxygen to chlorine. This is not dative bonding, because dative bonding, you must donate the electron pair. Okay, so this is not possible. So this is 1 and 2. If you follow your 1 and 2, means it is B, option B. Okay, in your syllabus. Yeah. Now, this one is the, again, what is being asked just now, which I explained to you, which is true of every nucleophile. Okay, so the question that Josh asked, is it all the nucleophile going to be negatively charged? Okay, the answer is no. Okay, so don't go and select this. It must be negatively charged. No, the definition of nucleophile, they are attracted towards the nucleus because they want to go for proton, because they want to donate the lone pair of electrons. So this is going to be the answer. Okay, must be able to donate lone pair of electron. That is nucleophile. Now, here X has this, okay, it has a branch skeleton, okay, and a secondary alcohol functional group. Okay, maybe this one we wait first. You try on your own. Okay, number 10. Okay, now let's move on. This one also, please try on your own. Okay, this one I don't want to just teach you. Okay, then you don't appreciate. Yeah, please try on your own. Let me just go and select the one over here. Okay, now this one is going to be something that you will learn later. Okay, but since we have learned about types of organic reactions, so let's learn about this as well. You see, alkanes are saturated hydrocarbon. What type of reaction alkanes will undergo? Alkanes will always undergo substitution reaction. Okay, substitution reaction. So here you have 2 types of substitution reaction, and I told you, okay, For alkanes, okay, this one, even though they didn't mention in the textbook, I mentioned in my note, it's going to be free radical substitution, okay, under the presence of UV light, okay, and or sunlight. Okay, under the presence of UV light or sunlight, it's going to be free radical substitution. Okay, but I told it's fine to know substitution alone. Okay, it's fine. Okay, but here I'm just showing you, okay, how the question will be like. Okay, they are not going to ask you simple questions only. Yeah. Now this one, try on your own. Okay, let's try this one. I think this one we have done it before. Yeah. Okay, the empirical formula of phenazine. Yeah. So here, okay, again, there are certain things that are going to be not be shown. Okay, so you need to know which are the not shown. Hydrogen. Okay, so hydrogen and carbon are not shown. So carbon, 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 carbon. You put all the carbon, and then you include the hydrogen. Okay, each carbon must have 4 bonds. So hydrogen, hydrogen. This one all balanced. Okay, all 4. Okay, hydrogen. Each nitrogen must have 3 bonds, so they are okay. This is okay. This is hydrogen, hydrogen. Okay, I hope you understand what I'm doing. Yeah. So here, okay, you can see how many carbon that you have. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have a total of 12 carbon here. So C12. How many hydrogens I have? So I count also 1, 2, 3, 4, 5, 6, 7, 8. And how many nitrogen that I have? I have 2. So they are asking empirical formula, the simplest ratio. So divide by 2, C6H4N. Okay, Nevan. Okay, this one all easy. Okay, but I think there are certain things that I want you to do, you do at home. Yeah. This one also quite interesting. Please try at home. Let's look at this. Okay, how many chiral center that will exist? And here you see there are different structure now. Okay, and you can see that, okay, especially this part. Okay, especially this part. Okay, we will consider, okay, whether they are going to be chiral or not. Okay, so you see here, okay, I want to see how many chiral center are there. Each of the carbon, okay, they must have 4 bonds. Okay, so you see this one, 2 bonds only, so there is hydrogen and hydrogen, so this is not a chiral center. Okay, this one not a chiral center because must have 4 different groups. So anything that is attached to the double bond, no, not a chiral center. Carbon not the chiral center because it's H3. Not a chiral center, not a chiral center. Not a chiral center because double bond. Same. Not a chiral center because double bond. Not a chiral center because 3 hydrogen. Not a chiral center because double bond. Not a chiral center because double bond. You can see here there is a double bond here, not a chiral center. There is a double bond here, not a chiral center. 2 hydrogen, not a chiral center. 2 hydrogen, not a chiral center. 2 hydrogen, not chiral center. Okay, this carbon, you can see here CH3 and CH3, not a chiral center, not a chiral center, not a chiral center. 0. Can Ashley? Okay, you need to analyze. Yeah, you need to analyze one by one. Of course, you are just listening to me. Yeah, but you need to try on your own. Okay, try on your own. There's so many things are here. Okay, where you can learn. Okay, like for example here, they ask you calculate how many hydrogen atoms are there. Okay, so just use whatever I taught you. Okay, like this is again. Okay, Josh asked earlier. Okay, when you have a line. Okay, does it going to be hydrogen alone? The answer is no. This line is representing carbon. This line representing carbon. This is carbon. This is carbon. And each carbon, they are bonded to 4 groups. Okay, so you see. Like that. and then you just see how many hydrogen. Okay, so hydrogen, so you see, just no need to write all the carbon. You know, each carbon must have four groups. So this is one hydrogen, so another two hydrogen, another two hydrogen, one more hydrogen here, two hydrogen, one more hydrogen here, two hydrogen. Each carbon, four groups is okay. Four groups is okay. So just let's see how many hydrogen that I have. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. So you need to do it systematically. Okay. So 22. Similar. Okay. Please, I'm not going to show you this. Okay. Try on your own. This one, please try on your own also. I have done this with you guys. Okay. You can also try on your own. Let me select questions that I feel very important here. Okay, maybe we try this. Okay, how many chiral center are there in one molecule of corticosterone? Okay, this one is the one also, yeah. Just now when we discussed, and then Josh also was asking this question also, yeah. So let's actually, not many times I'm actually referring to Josh, but he did ask. Okay, he did ask. So you see that, okay, each, okay, it will be quite difficult. Okay, quite difficult to identify optical isomerism because it's all joined together. Okay, but you need to use that assumption. Okay, the one that I mentioned to you. So here, okay, we need to look for the chiral center. This is not a chiral center because it is attached to two hydrogen. I'm not going to draw everything. Yeah, two hydrogen is there. This is double bond, so I don't want. Okay, and here for this carbon here, you can see here they have one different group. This carbon here, one different group. This is different and this is different, and they have one hydrogen. So definitely, okay, this is going to be chiral. This is chiral. Okay, now non-chiral, non-chiral. Okay, and here you see here this CH3, one group, another group, another group, another group. This is also chiral. You see here one group, one group, one group, another hydrogen. This is going to be chiral. Non-chiral. Okay, you can see here different group, different group, different group, another hydrogen. This is chiral.
Sir, is it like a lot of times the chiral carbons are where there's 3 or 4 intersections?
Not all, yeah, if you want to take it in that way, okay, then please take it in that way. So you see here they have 4 intersections, but here only 3. So you just need to analyze all the parts. If they look different, then they are different. Okay, it means even though they are joined together. Okay, this is the only best explanation that I can give, Josh. Okay, there is no specific way of telling that, yeah, please, all the what definition or this kind of a formula. No, it works that way. Okay, so you need to just justify like that. So here you see when you have this, okay, so this is going to be a different group here attached here. This is all, entire thing is different group. This entire thing, the one is going to be different group. There is hydrogen there, so therefore this is going to be a chiral center. This is also going to be a chiral center. No, no, no. This is chiral center. No, 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 no. Okay, this is what I can show you. Yeah. So here, okay, how many chiral centers that we have? Okay, even this one is not a chiral center. Yeah. So 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 chiral centers. So this is the part that I told you, okay, you need to analyze, okay. Don't take it as intersection or how many bonds and so on. You need to analyze, okay. If they are attached in a cyclic form, just analyze, just close this part. Like I do not know how to show it, okay. Maybe I'll just show it in this way. If you are looking for this, this particular, if you're looking whether you want to identify this as a chiral center, then you close the entire this part. Okay, if I want to say this is going to be one group, so you analyze, you ignore this, you ignore this, you ignore this, or this is one group, and then you want to find out this is different or not. You just think about this only, and you want to find out this hydrogen, just think about this hydrogen only. You want to find this is different, just think about this only is different. Okay, as long they are different. Okay, of course it's messy now. Okay, I do not know how to explain in a better way. Yeah, so this is going to be 7. Yeah, 7. It's already 10, but just give me time. Yeah, okay, just give me time. Okay, let's learn. Okay, I just afraid that I might miss certain things that I wanted to teach you. Yeah, this one, 27, very important. I prepared this question today is also to discuss something like this kind of question. Yeah. So here you're asking, they are asking how many cis and trans. Okay. How many cis and trans, not stereoisomer. Okay. How many cis and trans? And you can see here, there are double bond here, there are double bond here, there are double bond here. Okay. And if it is cis and trans, you're not bothered whether they have chiral center or no. Okay. You don't need to bother about that. So here, important is to find out the carbon attached to the double bond. They have different groups. H, okay, and this is going to be different group. CH, and then this is different group. Still fine. CH, different group. CH, different group. Fine for me. Okay, you analyze it. Make sure they are not attached to the same groups. Okay. So here CH and then the others, this is fine. CH and the others, it's fine. So it means that the one that possibly can give you cis and trans, okay, will be all these 3. Okay, all these 3. So the formula is quite simple. Just use the formula. It's going to be 2 to the power of n. So it's 2 to the power of 3. So it's going to be 8. That's cis and trans.
The formula only for cis and trans, right, sir?
Yeah, because I'm not including optical. Okay, if they say change the question, how many stereoisomer? Okay, how many stereoisomer that you have? Then you look for the chiral center. I don't think so. There is any chiral center here also. If they want, yeah, there's no chiral center. So even though they say how many stereoisomer, it's still 8. Okay, it's still 8. Okay, but this formula, yeah. Please remember, this formula is only for this stereoisomer. Okay, don't go and use this kind of similar formula. Mr. Gopi taught me this formula. How many structural isomer that you have for this? You cannot have use any formula for that. You have to draw. Okay, this one, that one, no one can save you. Even me or even formula, no one can save you. That one you have to draw on your own. Yeah. So sometimes I'm telling you, it is difficult. Okay, whenever they ask you how many different types of structural formula that they can form, it is very difficult. Okay, but sometimes they do ask that. Yeah. Now, here, I want to show you this also. Student X stated that 17 carbon atoms in all the 4 rings. Okay, what are the 4 rings? All these 4 rings. And they say that all the carbon over there in that 4 rings, they are all in the same plane. Okay, same plane means like if you put it on a piece of paper, they are just on the piece of paper. Is that correct or no? The answer is, okay, you look at this carbon here. There is a carbon here. If you have carbon and they are bonded to 4 groups, or if they have 4 bonding, okay, I think simple thing here. no need 4 groups. If they have 4 bonding, what kind of structure will they form, Ella?
Tetrahedral.
Yeah, tetrahedral, and they are 109.5 degrees. So that is already going to be a giveaway, that saying that this carbon, they are this carbon and this carbon and this carbon and this carbon, they are not in the same plane. They are going to be in this form. Okay, they are going to be arranged in a way that, okay, this one may be coming out and this one may be going behind. I hope you can visualize this. Okay, because this is, I'm talking only for this carbon, this carbon, this carbon, and this carbon. They are not in the same plane. Okay, automatically, because they are bonded to 4 different groups. Okay, they are not going to be at 90 degrees. This is what we learn in our chemical bonding. Okay, so definitely no. Okay, definitely no. So that one, definitely this student X is wrong. Okay, student X is wrong. Student Y, this is what I want you to see also. Student Y stated, okay, that this molecule displays cis and trans. My question here is, okay, I will only end this lesson if this one is correct. Yeah. Okay, let's see. Dylan. Okay, the fate of everyone depends on your hand now. Do you think, okay, okay, cholesterol have cis and trans?
No.
Yeah, no. Okay, why? Because the double bond here, they are connected to here, the group. There are free group hydrogen, only one free group. This is also connected. So if they are connected, there is no way for them to move. Okay, there's no way for them to be rearranged so that you form cis and trans. Therefore, student Y is also wrong. Okay, so the answer, which one is they are correct? So both of them are wrong. Yeah, so that's going to be the answer. Okay, the others, I think, okay, I think the rest not so pressing. Okay, not so important. The important part I have covered today, okay, with you. But the others, that doesn't mean the others not very easy. Yeah, okay, the others are tough also. Yeah, so please try. Okay, please try. I will discuss also again tomorrow. Tomorrow is Thursday. Yeah, yeah. Just now I accidentally entered your class thinking is Thursday. So because our class is 8 o'clock on Thursday, right? So then only I noticed that Mrs. Samuel was still talking over there. Then I checked my schedule. Anyway, so we still have one more day. Okay, still have one more day. Friday we don't have class, but Friday is going to be the test, 1:30 to 2:30. Yeah, so that is going to be what's going to happen. You still have one more day to ask me questions. So the only question that you can ask me is all based from this worksheet. Okay, so please try the worksheet today. Okay, and then tomorrow I will give you the marking key for the 32 questions or 31 questions. Okay, thank you guys. Okay, have your break. See you. Bye.
Sir, is there
Yeah.
an answer for this worksheet?
Yes. Okay, but I was planning to give you tomorrow, or do you want it now?
Anyway, it's fine. Just
I still want you to do it. Yeah, so I'll give you tomorrow. But I have the answer key. For those who needs the answer key, message me personally. I'll pass you personally.
okay.
Okay.
Thank
For the worksheet you already sent, is it?
Yeah, the worksheet is already sent. If you need the answer key personally by today, so you message me personally. Okay, but tomorrow I will send both. See you. Bye.
Bye, sir.
Bye, sir. Thank you, sir.
Yeah, see you.
Bye, sir.